Okay, so we've talked about just simplifying radicals. We've talked about what happens when you multiply them. So today we're going to talk about what happens when you're dividing by radicals. Okay, and I'm going to start off on this third one right here. So the problem is we do not want a radical in the denominator, all right? We don't want this square root symbol down here in the bottom. So we've got to do something to get rid of this. So the process I'm about to show you right here is what we call rationalizing the denominator, all right? So just follow with me. You'll see where I'm going with this in just a second. What I'm going to do is I'm going to look at the denominator. In this case, it's a square root of 2. So what I'm going to do is I'm going to multiply by square root of 2 over square root of 2. So again, all I did, just look at the bottom here. It's a square root of 2, so I'll multiply by that thing over itself. Now, let's think about this. Okay, square root of 2 over square root of 2. What is square root of 2 divided by the square root of 2?
1.
It's 1, right? So, really, I mean, it looks weird, but really all I'm doing is multiplying by 1. And if I multiply by 1, does that change what the number is?
No.
If you multiply 37 times 1, does that change the number? No, it's still 37, okay? Now it's going to change what it looks like, but it's not going to change the actual value of the number. So all I'm doing here is I'm multiplying by 1. Okay, so let's go ahead and do it now. Let's go ahead and multiply across. So on the top, what's 5 times square root of 2? 5 square root of 2. That's easy enough. And then on the bottom, what's the square root of 2 times square root of 2?
Square root of 4.
Is square root of 4.
4 2.
Okay. Now, as I look at the numerator at the top, the 5 square root of 2, is there any simplifying I can do to 5 square root of 2? No. So I'm just going to leave that alone. Now, on the bottom, square root of 4, can I do anything to that?
You can put it as 2.
Yeah, what is the square root of 4?
2.
It's just 2. And that happened by design, okay? That's not just by chance. That's what I did whenever I multiplied by the same thing here. 2 times 2 ensured that I was going to get a perfect square here, okay? If this was a 3 and I put a 3 here, 3 times 3 is going to make this 9. That's going to be a perfect square. It's going to be 3. If this was a 4 and I put a 4 here, this is going to be 16. That's going to be a perfect square. So by doing this, I ensure that the bottom number here is a perfect square and that every time it's going to just give me a whole number answer whenever I take that square root. Okay? And so that's it. That's what I want. There's no other simplifying I can do to that. And you may look at that and say, okay, you started off with 5 square root of 2, and now you got 5 square root of 2 over 2. How can those two be the same? They are. If you type both of those in your calculator, you would see that it gives you the exact same decimal number. It just looks different, and the way that I want it to look without that square root in the bottom. Okay, so on this next one, I have 4 over the square root of 7. Again, I do not want that square root down there. So what do you think we're going to do here? Multiply by square root of 7 over square root of 7. And again, square root of 7 over square root of 7 is just 1. And I can multiply anything by 1. It's not going to change it. So on the top, what do we get? 4 square roots of 7. And on the bottom, square root of 49. And then to finish that up, on the top, there's nothing I can do to simplify 4 square root of 7. So I'm going to leave it like that. Then on the bottom, what do I get? 7. Square root of 49 is just 7. And then there you go. Okay, next one. What am I going to multiply by here? Square root of 5 over square root of 5. So on the top, what do I get? 20 square roots of 5. And on the bottom, what do I get? Square root of 25. Okay, so that's going to give me 20 square root of 5 on the top. There's nothing I can do to simplify the top part. And then square root of 25 is what?
5.
It's 5. Now, here there's a little bit more simplifying I can do. Like on this last one, I had 4 square root of 7 over 7. There's nothing I can do to that. On this one, 20 square root of 5 over 5, what simplifying could I do? Yeah, what's 20 divided by 5?
4.
It's 4. So this just turns into 4 square roots of 5. And again, we started off with 20 over the square root of 5, and we ended up with 4 square root of 5. Those are the same thing. If you typed them in your calculator, you'd see they give you the exact same decimal number there. All right. Next one, we have square root of 8 over square root of 3. Okay, and that's the same thing as saying So we had square root of 8 thirds. That's the same thing as saying square root of 8 over square root of 3. Okay, it's the same thing. So I'm going to go through the exact same process. It's just we have a square root in the numerator now, but it doesn't change the way I do this. So what am I going to multiply by here? Multiply by square root of 3 over the square root of 3, which up top, what do we get? Square root of 24, and on the bottom we get square root of 9. Okay, so in the denominator, square root of 9 is what?
3.
Is 3. Can I simplify square root of 24?
Yes.
Yes, like we've been doing. So what is it? 6 times 4, which is 2, 3, 2, 2. Oh, sorry. And then got that pair right there. So what would 24 turn into? 2 square roots of 6. Okay, is there any further simplifying I can do on that? Nope. Okay. So that's how you do that in general. Now I want to jump back to the first one real quick. I wanted you to see that before I did this one. So on this one, okay, again, this is the same thing as square root of 49 over the square root of 4. Okay, now on this one's made to be real simple. So up top, square root of 49. Can I simplify square root of 49?
Yeah, 7.
Yeah, it's actually just 7, right? And on the bottom, square root of 4 is what?
2.
Is 2. So on this one, they were already perfect squares, so I didn't have to do anything. So you'll see some like that. Okay. Yep. Let's see. Yeah, I think that'll get it. That's the basic idea of what you're going to do there.